Hello, in this video we're going to look at an example related to the chain rule, and the idea is the following. If u equals x to the fourth times y plus y squared times z cubed, where x equals r times s times e to the t, y equals r times s squared e to the negative t, and z equals r squared sine t, find the partial derivative of u with respect to s when r equals 2, s equals 1, and t equals 0. So first of all, let's figure out the formula for the chain rule. And to do that, we're going to draw our tree. Okay, so the tree for this problem is pretty big. At the top of the tree we'll have u, and u is a function of x, y, and z, and each of those are functions of r, s, and t. And since we're interested in finding the partial derivative of u with respect to s, we need to look at all the branches that start with u and end in s. Okay, so there'll be 3 branches like that. And so let's write in the partial derivatives. U over x, that's the partial of u with respect to x. And then x over s, that's the partial of x with respect to s. And then we fill in the other branches in a similar fashion. And this gives us the formula for the chain rule, which would be du ds equals, multiplying down the branches, we have du dx times dx ds plus du dy times dy ds plus du dz times dz ds. Okay, so the next thing we need to do is we need to compute all the pieces, and then we'll put them into our formula. So first of all, let's figure out what is du dx. Well, du dx is 4x cubed y. Let's compute du dy. That is x to the fourth plus 2y z cubed, and du dz is 3y squared z squared. Next, we'll need to go through and find dx ds, dy ds, and dz ds. And if we go through and do those calculations, we find that dx ds is r e to the t, dy ds is 2rs e to the negative t, and dz ds is r squared sine t. The other piece that we need to figure out is that when r equals 2, s equals 1, and t equals 0, what does that tell us about x, y, and z? Because we'll need to know what all those numbers are in order to plug them into these partial derivatives. Okay, so x will be 2 times 1 times e to the 0, which is 2. Y equals 2, and similarly z equals 0. Okay, so let's plug all of that information into our computation. So first of all, to find du dx, we need to plug in what x and y are, and we know that those are both 4. And so when we plug that in, what we get here is we get 4 times 2 cubed times 2. We also need to multiply that times dx ds, and dx ds is right here. Plugging in our values for r and t, that works out to be. And if we continue in that fashion for all the other terms of our problem, we get 64 and we get 0 in the last term. And working that out, our final answer is 192.